Hi, this is Margo. This is Sunday, late afternoon, August the 7th, 2022. I hope everyone is safe and doing as well as possible. We made it through another week, and I know it's getting harder for most of us to get through the week. There's always something new, something unusual, but that's to be expected as we head into the latter days here, and so we have to remain strong and vigilant and adaptable and able to adapt to new situations and surroundings and things like that as best we can. So I'd like to welcome everyone to the show tonight. This will be my weekly update that I'll be putting on YouTube. We're going to go over climate-related items from Climate Reanalyzer, and we're going to go over methane from NOAA and CAMS, and we're going to look at sea ice and some earthquakes. But I want to start out, I had covered this from Sam Carana. This is his latest blog post. I don't know if I just overlooked this when I presented the blog post before, or if he added to it. He has a tendency to add to it. But this is his post on the Arctic sea ice. And here's this interesting section on the blob, which is a part of the North Pacific. Here, I'll show you exactly what he's talking about. We turn on the sea surface temperature anomaly. It's this red spot up here, what I call the evil eye now. See, it just fills up this whole middle part of the North Pacific. It looks like a big eye, and it's these sea surface temperatures. I think they need to do a new chart, because he shows them going up a lot higher than this chart. The highest the chart can read is 6C higher than normal in this whitish pink zone. But so I'm just going to share this little part I found that was really interesting, and it's a history of the blob, and he calls it the blob, and that's what I've been calling it too, until I switched over to call it the evil eye. Okay, a 2022 study of the blob, a warm water area in the North Pacific that began in late 2013, concludes that the unusually warm waters were transported northward from further south. The researchers found that abnormally warm temperatures extended 1,000 meters or 3,280 feet below the surface. So that's warm waters below the surface. And the above image shows the blob on July 24th, 2022, with sea surface temperature anomalies as high as 10.5 C or 18.8 degrees Fahrenheit on July 24th. The North Pacific Current is visible extending eastward from the coast of Japan. So it looks like this is from Earth Null School. And a little bit more here. Arctic News has long warned, e.g. in this 2017 post, that changes in the jet stream can strengthen storms that can in turn cause a large amount of warm, salty water to abruptly move north and enter the Arctic Ocean from the Atlantic Ocean and trigger destabilization of methane hydrates at the seafloor of the Arctic Ocean, resulting in eruption of huge amounts of methane that could drive humans into extinction in a matter of years. So I just thought this little section on the blob that just caught my eye today, and I wanted to share that. So thanks, Sam, for adding that, or putting that in there, and I just now found it. But so that's the blob. So there it is, the evil eye. Now sometimes we see a blob down here in the South Pacific. We're not seeing it right now, but we definitely are seeing this. It extends, through the whole central part of the North Pacific. And then I've been also pointing out this warm water around Kamchatka, Russia, and how that's unusual. We haven't seen it like that before. So there's that little tidbit. So we're going to start out with the 2-meter air temperature around the globe today. In the Arctic, we're still seeing mainly different shades of green, and the darker greens are creeping in over the Arctic basin. But we have a tiny bit of aqua, which is right at freezing, or 0 degrees Celsius, right here on the west side, but the rest is all in some shade of green. And here in North America, from Texas up through the central part of the U.S., that's in white colors, and that's 40 C or higher. So that's 100 degrees or higher. And then here, Arizona and Southern California, they've got some whites going on. And here, we've got it coming across Africa, Saudi Arabia, Iran and Iraq, and all these areas over to India. It's still hot, it's still summer. We've had some cooler temperatures in the Reno area, which has been a relief. We got some rain this week too. Our power got knocked out in my neighborhood on Wednesday night for about 2.5 hours, so I got to use some of my prepping skills for that. I'm also preparing for rolling blackouts that are most certainly coming as we move into times when there's not going to be enough electricity for all the grids to be up all the time. And so we'll have some rolling blackouts. And so, there are some things we can do to be ready for those hours, and maybe days. Hopefully it's not days. Sometimes, it just can't be helped because of different weather events. But, as long as we know what we need to prepare for, we can do that. And not be so anxious and be able to get through. So here, this is 2-meter temperature anomaly. look at this at Russia. Now, there are fires in this area, but this whole area in northern Russia, next to the Kara and Barents Seas, this has been in a lot warmer temperatures all week, and there's huge methane just billowing up here and in the ocean, and it's also coming up non-stop around Komsomolets right now too. And we've got browns here in northern Canada and western Canada here, slipping down. See the blues? That's the cold air, because we don't have any jet stream anymore. It's jet loops, and with the loops, the air is not held in the Arctic, and so it slides down right next to the warmer air. And we had some of that blue down here in the Reno area a couple of days this week. And it's not too bad today. I haven't turned on the AC. I've got my windows open and a fan going, but it's not bad. And we've had very little wildfire smoke so far this year, so I've been very grateful for that. Compared to the last 2 years, and especially last year, it was like everything was on fire. Couldn't see the sky for days because of the smoke, but we haven't had near any of that, and it's actually been very tolerable so far, so I'm grateful for that. So here's the flat view with the 2 meter temperature anomalies. Let's see. And you've got blue right next to the browns. Worldwide, we're up 0.1 C higher than normal, so the overall temperature is down a little bit right now. The northern hemisphere is up 0.7 C. The Arctic is up 1 C higher than normal. The Antarctic is down 4 C lower than normal. Southern hemisphere is down 0.4 C, and the tropics are up 0.3 C. And here's precipitation and clouds. Now the green is rain, the blue is snow, and you can see just patchy areas of rain all across the Arctic. We've had some kind of rain every day up here on some part of the sea ice, and so the ice is collapsing in some areas really quickly. We have about 5 to maybe 6 more weeks of melting before we reach the minimum ice extent in the Arctic. I don't know, we may go longer this year. I always have that feeling that it may not stop in mid-September. So look at the rain here at Iceland and coming up to Greenland, and rain across the Arctic basin in some places here, and so on. And also out here the Barents Sea and the Kara Sea. Here's the flat view. Lots of rain from India over. See all of that. And here are the jet loops. See the loops? It's almost like a figure 8 thing. And the cold air swoops down through those jet loops. And it just looks worse every time it's just very random, no rhyme or reason anymore. See all these breaks and big loops up, and then kind of one straight across, then another one, and then here's another one around the equator. Then the southern hemisphere has 2 or 3 going on. And we'll look at sea ice and snow cover with the slideshow. Here's sea surface temperature anomaly. This is for yesterday, the 6th, and you can see that we've got more colors every week when we look at this. Wherever the ice is already melted, the water is heating up. Here in the Laptev Sea, we're seeing up into the light pink, which is 6C, higher than normal. We've got browns here, browns in the Chukchi Sea, browns along the Alaska and Canada coastlines, brown, dark brown up here in the North Baffin Bay, brown around Greenland, Iceland, and all of this brown in the North Atlantic coming into the Barents Sea, with red and pink along the Russia coastline, and then this Kara Sea is almost all in the light pink. And so this area on this east side of the Arctic is just kind of blowing up, and you'll see there's a lot of heavy methane coming up off of the land and up through the water too. Here's our evil eye in the North Pacific, and we've got red around Newfoundland. Look at the heavy brown coming all the way across the Atlantic. We've got brown filling up the Gulf of Mexico, and brown on this whole west side of North America down. And in the interior water areas, the Mediterranean on this west side is reddish brown, and then more browns. The Black Sea is brown, Caspian Sea is brown, Persian Gulf is brown, and then here all around Japan, between Japan and the mainland, we've got red and brown. Sea of O coast is reddish, and around Kamchatka it's red and pink and brown. And then this from the Pacific over here in the north, it's all brown. And then in the South Pacific, we've got brown coming across. So these ocean temperatures are, I mean, that's a huge factor in the extinction. So worldwide, we're up 0.5 C higher than normal. Northern Hemisphere and North Pacific are both up 0.8 C. The North Atlantic is up 0.9 C. Southern Hemisphere is up 0.2 C. And the Equatorial Pacific is down 0.3 C. That's the blue. That's the Equatorial Pacific there. So there's that. Now, I've got 2 days worth of NOAA data to share. We're going to start with Friday the 5th in the morning on the MET-OT-B or MET-OT-1 satellite. And remember that the MET-OT-2 satellite, they retired that one for the methane information. I think it was back in November, so we only have one satellite now, this MET-OT-B or MET-OT-1. And we're tracking the 469 millibar reading. The mean or average was 1939 parts per billion. The high reading was 2405. We've got pinks coming all the way down to the Antarctic coast. The pink is a zone. It's a range between 2,000 and whatever this highest number is in the parts per billion. In this case, 2405. And so we've got pinks covering most of the northern hemisphere. And then in the afternoon, even with the missing data, the mean was 1940 parts per billion. The high reading was 2385. And then for yesterday, the 6th in the morning, the mean was 1940. The high reading was 2452. Look at all this missing data. All of South America, a little bit of Central America, a lot of the East, US and Canada. And so we're missing a lot of methane here. Even with that, this mean is still 1938. It would have been higher with all that missing data. It probably would have been around 1940. And the high reading was 2360. Here's the chart and spreadsheet. I've been tracking this since 2019. Started out tracking with Nostradamus, or Dave, and he was tracking a lot of different levels, and then I decided to just kind of track my own, and so I settled in on the 477 millibar reading, and so have been doing it, but we're both tracking it. So thank you, Dave, for turning me on to this. So for the 6th, that averaged out to be 1939 parts per billion. That gave us an overall increase this week of 3.5. See, the line is straight up. So we've gone up 4 weeks in a row now, and this next line is the 1940. Now last year we peaked out. Our highest methane reading last year was on October the 2nd at 1936, and we reached that a couple of weeks ago, just during the week, and so we've surpassed that, and now we're at 1939, and we're headed up. That's all I can say. And we've still got, usually methane keeps going up until around sometime in October, usually early October, but it got kind of a late start. You can see it kind of was just kind of treading water for a while there, but now it's zipping up. So, it might keep on going after October. I just don't know. We're 18 parts per billion higher than this time a year ago, and we're 69.5 parts per billion higher than where I started this on March the 1st of 2019. So it's exponential. Now let's see what happened this week. So here we were in my show last Sunday. Here was the Saturday data. We were at 1935.5, and we had gone up 3.5 that week, and we were at 17 parts per billion higher than a year ago. And then on Sunday it went up 0.5. Monday it jumped up 2 parts per billion. On Tuesday it went back down 2 parts per billion. On Wednesday it jumped up 2.5 parts per billion. On Thursday, it went up another 1.5 part per billion, and in the afternoon, that reading was 1941. That's the highest we've seen on the individual means so far this year. And at this point, we were 4.5 higher for the week. Then Friday was 1939.5, so it went down 0.5. And then Saturday, 1939, so it went down another 0.5, bringing us for a weekly number for the week at 3.5 higher for the week, and 18 parts per billion higher than a year ago. So what we're seeing is every day, and I've been tracking this daily for a couple of years now, we're higher, this much higher than a year ago. So we're setting records every day. And even if it goes down a little bit, it's still, 18 parts per billion higher than it was a year ago. And, 40 parts per billion higher than 2 years ago. So we never go back down as low as we did, the year before. And then we're always at a higher level to start out on the warming, and so we end up going past the highest from the year before. And I was just thinking, if we had temperatures that just kept going up like this and setting a record every single day like this, people would be flipping out. I mean, they would be flipping out. There would probably be riots. But we don't see that. And so, but here we are. And the same thing with carbon dioxide. And I don't really track it that much on a usual basis. I just kind of stick to methane. That's my thing. But this is incredible. I mean, this is just incredible when you see the peak here, and here was the peak the year before, and then here was the peak the year before. So this is the the fourth summer that I'm tracking this. So there's that. Alright. Now we'll move on over to CAMS. This is the Copernicus Atmosphere Monitoring Services website. We're going to look at Saturday the 6th, Arctic view and surface level. Here's our color chart at the bottom. And now that I'm using my old monitor again, we're able to see the color chart along with this, with the movie here. So I like that. Yeah, my other monitor burned up. That was awful. It was this burning plastic smell. I couldn't figure out where it was coming from, whether it was my computer or what. And so I took the computer in. It wasn't that. And then it took me about another week to figure out that it was from the monitor. So I'm glad I kept my old monitor. So the data is for Saturday, and the forecast period is Sunday through Wednesday. It's popping off here in southern Iceland. The volcano is still erupting there too. I saw some recent video live cam on that, so that's kind of a constant, I think. It's also popping off on the north end, and we still have our problem spot here in the North Atlantic, right there off the coast of Newfoundland, right there, see, and from Norway over to Russia, see the heavy, see it, the waves move out, very heavy. And then this area with the heavy methane, there are a bunch of fires burning here. There are also fires burning further west and west and south as well. But you can see this interior of Russia really coming to life with the higher readings. Here's Komsomolets, and it looks like whatever has opened up in the seafloor, it looks like it's worse and just going exponential now, and it's just constant spewing, and you know, all the research papers talk about the Laptev Sea, but I'm talking about this. I mean, why doesn't someone just drive a drone over it, fly a drone over it and test it, or send a drone to the bottom of the seafloor and see what kind of methane craters are blowing open down there or coming back to life. We can also see higher background colors. See, the main background color here in Russia is this light yellow-green. That's about 2,000 parts per billion. Right there, see? Alaska, the interior. Here's Koktovik, Canada. Here's the tar sands here. Here's North Dakota. Here's this area south of the Hudson Bay that's high. And then here in the U.S., we've got blobby areas and waves of green. See that? See the wave of green coming? It's actually coming off of the land areas and coming across the water. So we're in this methane dome here, and we don't even know what it would be like, what the air would be like without the dome, because we've been under the dome for so long. I can't even imagine how different the air might be in an area where the background color is the blue. Well, I mean, we've got some blue here in the western U.S., but it's mainly greens. And if you live in any kind of city, you're gonna be in the dark color. If you live in any sizable area, you're gonna have methane in this highest reading, because cities just make methane from everything, from the dump to sewage to you name it. Then you got oil drilling and natural gas and whatever. Okay, this is the North Pole view, and so we've got higher readings coming off of Europe. See the high readings moving out across the Atlantic here. So here's the UK and Ireland, Germany. Those are pretty blobby. Here's the Persian Gulf, that's filled up. Here's India. This blob just west of India is Pakistan. So that's just solid all across China and comes up into southern Russia there. See the waves. And then here in the US, watch, here come the blobs. See? That's the upper Midwest over. Here's Mexico. And if you want to see, I wasn't planning on showing North America, but if you want to see just how much different it is to see one of these areas close up, I mean, you really get an appreciation for the specific areas. And when it pulses higher, that's when it's when the when the sun's up on this side, and then when it goes down, that's in the nighttime. See up here, and then see the hot spots that pulse up and down, and even here in the Reno area. See, it's a little dot, but you know, it's in the high range because it's a city. I mean, if you lived out in the country, it'd be probably better unless you're next to an oil well or fracking field or something, or a livestock place, or fertilizer, all of those high methane. There's that. Alright, now we'll go down to the Antarctic. This one's kind of boring right now. Okay, so we can see this background color here is up at the 1860 reading, and we've got some green streaming down here from South America, here from, I think that's Australia over there, Australia here, but we don't have any of the 1840 readings anymore, so, and we can't really discern where it's coming up around the coastlines because it's just the same color, or pretty much the same color. These colors, the changes in them right along here, 1860 to 1880, 1900, they're very subtle. It's hard to tell. Alright, now we'll go to the global view. See the dome? You can see the green all around North America. I mean the northern hemisphere. And really where people are, where a lot of people are, you're gonna have those higher readings. See, South America, Australia, see around the coastlines, see that, New Zealand. Oh, I had a coughing fit. I always have to pause 1 or 2 times to have a coughing fit, it seems like. There's that. Now we'll look at 500 HPA. So this is about at the same level as what we're tracking on NOAA. Look at all this dark from Pakistan over. Look at it coming up and around Russia. Here's some. This is I think that's Komsomolets area, and here Saudi Arabia and Egypt and across, and then look at this heavy coming up around Canada, and then these higher readings are coming further south as well, higher colors. Into the reds and oranges, see. And then total column. This is where methane is added up through all the layers of the atmosphere, and we can see. Here's Japan, and it starts in the ocean there. Look at this big swath of the highest readings all the way across China, Southern Asia, India, Pakistan, and then here's the Persian Gulf, across Saudi Arabia, the Red Sea, and over into Egypt, and then the reds, oranges. It's just awful. Alright, so there's methane. Now I'll share the rest of the things from CAMS here. This is the smoke, back to the Arctic view, and this is wildfires and smoke here in Russia. You can see kind of further south here, and then here in the middle, and then over on the east side in Siberia. There's smoke over the water there, we're not seeing that much smoke and fires here in North America, not yet. I mean, it's really minor compared to what we're seeing in Russia. Here's sulfur dioxide today. Here's 500 HPA. We don't have any super huge readings. It's just kind of the usual. And here's the ozone over the Antarctic today. Now, we've been down in the danger zone. There's a hole that has been kind of morphing this week. We're not seeing it in the danger zone right this second, but we've got aquas and all these greens. I mean, it's all under the solid yellow, which is considered average or good, and or a good thickness. We've also got aqua here on this west side, and all, I mean, it's huge. This hole is, you know, it spreads way out further than just around the Antarctic. Here's the Arctic ozone, and we can see a hole, and thinning over this whole Beaufort Sea and western side, Chukchi Sea, in these areas, almost all the way to the North Pole. And then we've got definite hole over most of Siberia and Russia there. And see, that's in yellow-green, so all of that is thinning out. And see this area over Novaya Zemlya and Kara Sea and Barents Sea. And this can be from a couple of different factors. High methane will eat away at the ozone layer. Also, the fires and the smoke, all the noxious stuff from fires and sulfur dioxide, all of that will eat away at the ozone. Also, geoengineering eats up the ozone layer, and they're doing plenty of that. I don't really get into it that much. I mean, on my shows, I mean, I don't, but I follow people on that. And here's the global view. Here's this perpetual aqua. See, it's over northern Australia and west into the Indian Ocean. And see all the greens. Here's a break all the way up in the Atlantic. That's all of those. Now I wanted to show, before we move on to sea ice, let's go. I wanted to look at ozone a little closer here. Here it was yesterday with the hole. See, that's the danger zone. This bluish purple, the chart, it's in Dobson units. That's between 200 and 220 Dobson units, and the thick black line is around that color, denoting that that's anything in that black line is in the danger zone. And so we've been seeing it off and on for most of the week here. See, what happens is as the ozone moves around, you know, the thinner part will open up, and then it closes up a little bit, and then it'll open back up. Look at this big hole that they're showing in the forecast over this western side. That's not good. Now that's in the forecast period. And then another one opening up on the top right hand side. Alright, now let's go. That was starting yesterday. If we start today, see, it's closed up. Now let's load up the movie again. And so the data is for today, and then the forecast period is Monday through Thursday. So let's see. See, here comes starting Tuesday. See the hole moving across. Here's another one. And let's see. Oh, look, it opens up on the south end by Thursday instead of on the northern end. So you can see it turning around. Look at this. And these areas are still in the dark. The sun is just starting to peek over the horizon. So there's that. Alright, I just wanted to show that. Now we'll move on to sea ice. And we can close that one. Oh, I don't have everything opened up. Hold on. Okay, here we go. So we'll start with our slideshow. These are images that I save daily from Climate Reanalyzer. And here we are today with sea ice and snow cover. We can zoom in, and just a little wisp left here in the Baffin Bay. And these areas, all of this area is considered the Northwest Passage. These tributaries in Canada, and this bottom one is open. You can see there's no ice down there. See the darker coming in? That means it's almost all melted, or it's coming apart really fast. We can see the Beaufort Sea is collapsing. This is one of the areas that it's been raining off and on, and also it was raining in the East Siberian Sea and the Chukchi Sea this week. So see the change in the color. It's really coming apart there. Then here's the North Pole. There's an area just east of the North Pole that's really opened up, and then all the way up north to the Laptev Sea. And then here's one area kind of in the middle where there's just lots of open water. You'll see when we go to NASA Worldview. And the edges are shrinking as well. Here's Svalbard, see, open. Novaya Zemlya is open. Severnaya Zemlya, parts of it are open. This whole Russian coastline it's pretty much open. There's just a little area over here next to Siberia where there's a little ice right next to the coastline. Otherwise, the whole Russia coastline is open. So let's see what's happened this week. Here we were last Sunday on the show on the 31st. And so let's just go through. Here's Monday, Tuesday. Look at that change. See here in the Chukchi. See, that's when it was raining there. Here's Wednesday, Thursday, Friday, Saturday, and then here's today. So there's that. Now, move on to the other models. This is from the U.S. Navy. Arctic sea ice thickness. This is as of yesterday. This is the latest data. And here's our chart on the right, and it goes backwards in the rainbow from the thinnest to the thickest, and you're not going to see a bunch of reds or yellows or greens. You're going to see some aquas down here just above Canada, a little bit above Greenland. And the aqua range is the dark aqua is about 1.5 meters thick, like here on the edge there. The brighter aqua is about 2 meters thick. The real bright aqua is 2.5 meters thick, where it's moving into green. So, and then we've got the dark blue is about 1 meter thick, I think, about 1.25. The dark purple is about 1 meter thick, and then the medium purple is about 0.5 meter thick. So this is what we've got as of yesterday. Let me zoom in. And right here above Greenland, there's here's some open areas along the coastline where it pulled away, and this ice is collapsing. See the dark coming in. So no more bright aqua up here, and so this whole area was the thickest ice, and it's shrinking down, and it's also getting thinner and breaking apart as it's shrinking down. And it looks like this part on the west side, I'm thinking is going to break off and then just get churned up in this Beaufort gyre. And you know, once it's not attached to the coastline anymore, and it's just floating freely, anything can happen, really. That just gets sloshed back and forth, and depending on the wind and the waves and whether it's raining or not, we could have a cyclone. This is the time of year for Arctic cyclones to form, and we've seen Arctic cyclones form like in early August, late August, and it just churns up the sea ice, what's left here, and can be devastating for what's left up here. There's a little hint of green that's about 3 meters thick, but and a little spot of red here by Greenland. I'm not seeing any dark red. Little bit of yellow here by Greenland, and see the darker areas. That's where the ice is breaking up and it's just pulling apart. And here at the cross lines, this is the North Pole, and it's right in between, like the dark blue and the dark purple. So that's right around 1 meter thick at the North Pole. And here's the Beaufort Sea. There's a lot of white showing through. And this area, quadrant 1, is really thinning out. Then quadrant 2, again thinning, and just more of the same. Here's the 30-day animation. This was updated to yesterday, so the data goes back 3 weeks, and the forecast period goes out to next Saturday. So let's see what they're showing on this model. So next Saturday is the 13th. Now usually the melting slows down around mid-August. It still melts, but just not as fast, and it keeps on melting until it reaches the minimum, which is usually around mid-September. But you know, we're in no man's land. All bets are off. We just don't know. Anything could happen. So I'm going to stop it at the end. Okay, here we are on the 13th, and we're just seeing more and more thinning out, and all this white area, that's open water in between pieces of ice. See, so most of quadrant 1 will be in the very thin, or to the stage where there's just a lot of open water between pieces of ice. And quadrant 2, it's still thinning and retreating on the ice edge. Here's quadrant 3, and look at the darker. So this is the ice coming apart. And you can see more lines forming. These are the leads where those open up first, and then the large areas come apart. And also by next Saturday, we can see that in these tributaries, it's almost all in the lavender or light lavender, just a little bit of aqua. So as the ice drift moves the ice around, it can be exiting through through these areas, and also through the Northwest Passage. I'm having a brain fart. This area here between Greenland and Ellesmere, I'll think of it, at the nearest strait, and here exiting in the Fram Strait. And remember, we've got warmer water, and that's coming up underneath, and so it's eating away underneath the ice as well. There's no buffer. There's no more thick ice as a buffer. Here's the Beaufort view, sea ice thickness as of yesterday, and here's Alaska at the bottom. Here's the Beaufort Sea, still thinning, breaking up. Here along the Canada coastline, we have huge breakup. See all these lines and pulling away and folding under and sloshing around. Here's the 30-day animation, and the forecast period goes out to next Saturday. So let's stop this. Here we are. So here we are on the 13th. And it's coming apart and a lot thinner. See, we've got some purple in there, and see the lines, those are the leads opening up, and no more yellows or reds or very little green even. It's mainly shades of aqua and a lot of darker aqua. And then down here in the Beaufort Sea, just thinning, and white is open water. Anywhere you see white, even like this whitish light lavender, that's mainly open water. And here's the Antarctic. Now we're tracking the refreeze here. Again, this was updated to yesterday. And we can see still thickening here in the Ross Sea and a little bit around the coastlines. It's thickening here in the Weddell Sea. We're going into some greens now. So 3-meter ice here in the Weddell Sea. And a little bit more around the coastlines, and it's inching back out on the extent there. Here's the 30-day animation, again updated to yesterday, so the forecast goes out to next Saturday. Now this should keep extending until about mid-September. About the time we reach the minimum in the Arctic, we'll reach the maximum refreeze in the Antarctic. But we're well below, we're at record lows for this year down here as far as extent. It's record lows. So the refreeze never really took off the way it should have. And now, moving on to the next model. This is from National Snow and Ice Data Center. This is as of yesterday. This is sea ice concentration in the Arctic. The darker the blue it is, the more it's melted and coming apart. And so we're seeing blues over most of the ice. Just a few little areas of white where it's kind of more concentrated, meaning that the ice is put together better. But look, we're seeing a lot of blues even over this area where the thicker ice is. Here's the collapse of the Beaufort Sea and the Chukchi Sea, this East Siberian Sea that's melting really fast. And then here from the North Pole all the way up. Then this whole east side is pretty much in the blue. And these browns, that's the median. So we're well under the median. Here's the sea ice extent chart for yesterday. And the blue line is this year, the dotted line is 2012. This gray line is median, and we're still low. We're still dropping, not at as steep an angle as it had been, and we're still a little bit above 2012. But you have to remember that 2012 had a lot thicker ice. The ice was just a lot healthier and more multi-year ice, which we just are not. We just don't have that now. So the ice that we have is in very poor shape and a lot thinner, and we don't have to have the buffer anymore. So don't let this fool you, thinking that just because we're not at 2012, or below, that we're in good shape. We're in horrible shape. It's horrible. And we're seeing evidence of loss of the ice. We're already seeing evidence of that. So, of changes in the climate systems. Okay, here's the Antarctic with the refreeze. And see, we're under the median. See, it's doing pretty good on this southern edge. But we're under the median for a lot of it. And here's the extent regrowth chart. The blue line is this year. The gray line, the green line is last year. The gray line is the median. Now we saw it kind of stalling out about a week ago, and then picked back up, and we're at a little higher angle. So the refreeze is picking back up. We're still well under last year and under the median as well. Here's the Greenland melting as of yesterday, mainly on the western side and the southern, and then on the northern. But we're seeing spots all around with that salmon color. Here's the cumulative melt days for this year. See, we're getting up into the orange range And some of these, see on this west side, also up here in the north, 60 to 70 days of melt for this year. Now, as far as I know, we haven't had rain over the interior yet. We could still have it. Here's the extent chart. The red line is this year. The dotted line is median. And so we're jumped back up pretty much above the median. And according to the median, it should be going down. Looks like until about the 1st of September, and then it stops melting. But we'll see. You know, this year is totally different. We're about at looks like 12% melt right now. That's all of those. Now we'll move on to NASA Worldview. I'll refresh and get the latest. Okay, here's all our data. I wanted to show real quick, though, in the Antarctic. Here we go. So, see, it's mainly still in the dark. Just have a few edges coming into the light. Here's the Western Peninsula coming into the light. This is the Weddell Sea. That's the sea ice there. Now, I've been tracking this A76 iceberg. It's right here. See? And it's breaking free of the ice, and I think it's going to be out to sea soon. That's yesterday. We can see what it's done this week. So here we were last Sunday. It was right up here under that cloud. So here we go. Here's Monday, right there under the cloud. Here's Tuesday. Can't see it there. Here's Wednesday, right there. It's Thursday. See, it's still rotating a little bit. It's Friday. You just barely make it out under the cloud. And Saturday, see, that's a good view. See, this whole edge is open. There's ice on this bottom part, but it's got momentum. I think it's going to break free. And now that the sun is up, I'm thinking this will melt out. And here we are today. We can't see it. Too many clouds. So that's A76 iceberg. Now we'll go back to the Arctic and turn on sea ice concentration. And here's our blue marble layer. Look at that. Wherever you see colors, that's where it's melting. Here's the collapse of the Beaufort Sea going on. And see up here. Very little white just spotty areas of white, meaning good concentration where it's put together. But when you get yellows and greens, those are holes. A lot of open water. Once you get into the blues and purples, it's very spotty ice. See, that's in high melt in these tributaries. So let's go back. Here we were last Sunday. And we'll just see what happened this week. Oh, go back. So here we go. Here's Monday, Tuesday. Here's Wednesday. Look at that. That's from the rain. Here's Thursday, Friday, Saturday, and here it is today. So here we've got a big hole opening up in the Beaufort Sea. So now we'll turn the clouds back on, and we turn off that layer, and we still don't have any Earth at night layer. It's inaccessible. No data. Non-nominal. Those are their words. Here's some smoke over Russia. See? And the smoke gets mixed in with the clouds. Let's see. So where to start? Well, let's start down here at Greenland. Here's this northern tip. See how it's pulled away from the coastline. See, open water there. Now last week we had a really good view of the ice up here. We've got some cloud cover now. Here I was showing these melt ponds. See, they're still here. This is where the water, it forms water where the ice is melting, and it just pools up, melt ponds. They're big. When you look at, this is 5 kilometers. See, that's at least 5 kilometers long. Some of it is longer. So they're huge. Here's a huge one here. Look at that. Okay, that was on the 4th. Here we are back today. Let's go back. Here's the nearest strait. This is the Lincoln Sea. We've got clouds here. See, open water. And so the ice is passing through here. This is one of the exit points. Oh, here's a good view. This is from Friday. Look at this. See, you can see open water forming. Once you can see the open water, then you start seeing more and more and more. That means it's melting pretty good. Let's see. Anyway, let's go back down here. Here's the nearest strait. Here it comes. See, it's just going right through there. And here's the Baffin Bay. Can't really see it that well. Here's some melt ponds. See? Let's go back. Here we are today. This is open. Look at this cloud. This is all open, no ice here. Here's our ice sheet. There's the southern end. So this is, wait, no, we're not that far down. Okay, look. Those are pretty deep melt ponds, it looks like. Look at that. And then, I don't know why the ice is dark. I guess just from weather. See, that's the edge where it's sloping, I guess. If anyone has any ideas, just let me know. Alright, here's the southern edge. So it's raining down here on this east side. See the rain cloud? Here's Iceland. And here's this east side. See? Now let's go to the right. Here's Svalbard. This is open. Remember, the ice edge is right along here now. We can turn that back on. See? It's right. This is the ice edge here. Here, let's go up. So here's the North Pole, and just east of here is where we've been seeing it come apart. Now this is clouds or that fake layer that they put in to cover things up. See, there's a lot of open water there. Here, let's go to yesterday. Look at this. See? That's open water. That's coming apart. Look at this. Down here. And then a cloud. And then see this patch up here? See, that's open. We're looking through some kind of haze here. But that's open water there. Here we go. See? Open, open. Lots of open water there. We're going north up to the Laptev Sea. Look at this. There's some more. Look, all the way up. See? See, it just starts spreading out. Look at all that open water. And as it spreads out, there's more and more water between the pieces. Look at this. Here's 80 north latitude. And see. Here we are. See, there's the edge. So this is yesterday. Let's see. Oh yeah, clouds today, right there. So, here's Novaya Zemlya. See, that's open. Here's Severnaya Zemlya, right here. Right down here is Komsomolets. Now, another thing I like to track is this Vovolov ice cap. Okay, look, here's a little cloud, but this is the ice cap. You can see the ice pouring into the ocean. It's dumping right there. There was a really good view. Look at this on the 4th. And so this ice down here, I think, is left over from what's coming down. See the flow even? I mean, it's just pouring down. Wow. So the best day to see that was the 4th. That was Thursday. And so these islands, they have ice caps on them, and they're all shrinking. You see, look at that. And so here's Komsomolets. So that awful billowing methane is right around here, and also here in the North Kara Sea. So this is a good view of the ice. That's all Thursday. See? So this little passage is open. How much ice there? Here's some on the bottom side. Let's go. Look at this. Here on the west side. Here we are today. Oh yeah, lots of clouds today. So, we'll go on. Look at all these clouds. Here's the Taimyr Peninsula. This is the Laptev Sea. This is open, completely open. See if we can see. Here it was yesterday. See, it's shocking to see it like that around the coastline when just a couple of weeks before we were seeing ice. Now this is an area that we're seeing brown and reds on sea surface temperature anomaly. So it's heating up fast. See, that's open. This is New Siberian Islands. And let's go. Oh, that's awful. Can't see a thing there. See the clouds. It's hard to catch a good day. Here, on the 2nd, we can make out all these awful crosshatch things. but there's no ice here. That's what I'm trying to show. See, all the way around. No ice, no ice. Here's the ice edge. And here's Siberia. This is the East Siberian Sea. There's the ice. The green is algae. So, let's go. And here we are today. Can't see a thing. Bering Strait, that's open. Here's the Chukchi Sea. A lot of this is open. Here's the ice. You can see it coming apart there. See the little spots? They count all of that as extent. But look at all the area in between the ice that's absorbing heat. Here's Alaska. So here's the breakup of the Beaufort Sea. Look at that. That's what rain does. See? Look at this. We're looking through some clouds of some kind, but it's collapsing. This whole Beaufort Sea area is in collapse here. Let's go back. Here's yesterday. Here's a better view. Look. See? Look at this. This is, see? Here's the coastline, Canada, and here's Ellesmere Island. Here we are today, Ellesmere. Here's the coastline. See, it's melting inside here. See. Now, let's see what else we can see. Let's go north from Ellesmere. We're starting to see some little spots of open water. See, that's where you see like the dark aqua showing up and going into the purple, or the dark lines. That's where it's coming apart. So this looks like that's coming apart pretty fast. See all these little dark spots? That's open water. Here's some more. See? And there's the ice. Here's the dark spots where it's opening up. Now where are we? I got lost. Okay, there's the North Pole. I was trying to see how far I could go until I ran into a cloud. Let's go up a little more. Hard to see much up here. Look, there's some open water under there. There's the area we just looked at. Okay, here's the ice. See the dark that's opening up. Here's some more. See these long cracks? That's the leads where they're melting, and that's where the water is, or the ice is thin, where it froze in between the areas where it was thicker. But these are all opening up. See? So this area, that's where the thicker ice is. Okay, let's look at these tributaries. See, that's breaking up, see. This could all melt out. I bet all those people on cruises would be happy. Adventure trips. It's for the wealthy to do in the end times. Not me. My traveling days are over, and I'm not wealthy either, so I'll just stay here. Stay put. Documenting the end. That's what I'll be doing. Look at all this open. So there's that. Now we'll go over some earthquakes. Here's USGS, all magnitudes for the last 24 hours. We're seeing 210 right now. There were 38 that are 2.5 magnitude or higher. I don't see any huge ones. We've got some 5s. Here's a 5.8 Shiko 10 Russia. And here's a 5.1 Methane Papua New Guinea. And then we've got 4s. These smaller dots are 4s. And so on. And here in the South Atlantic, 4.8, and here 4.8 South Sandwich Islands, and so on. And today, if you're in Texas, we've got 3.9 and 2.6. Those are the largest ones in West Texas. And we've got a 3.5 at Baja. and 2.6 at Oasis, California. And then we've got some Aleutian Islands, 4.6, Unalaska. Let's see what Hawaii has. Oops, I'm lost. They've got 3 of the higher magnitudes. 2.5, 2.5, 2.6. That's not huge. They've got 24 here. Analyze 24 hours. And so let's see how many we've had this week. 7 days, all magnitudes. 2003 earthquakes this week since our show last week. And we've had Arctic earthquakes up here in the North Atlantic. Here's one, 4.1 in the Greenland Sea. This is just south of Svalbard on the red line. And we've had, how many on Iceland? 8 on Iceland. And they're all in the 4s range. 5.0, sorry, was the largest at Alftanes, Iceland. This is, I think this is near where the volcano is going off. Reykjavik, in that area. And let's see. We've had 5s. I don't remember seeing any 6s this week, because I report on those. And here in the lower 48 in the U.S., look at this. We had movement on the Juan de Fuca plate. See all of these? Movement up here in this Cascadia zone, Pacific Northwest, and then all the way down. See, this is the Walker Lane fault line that they're talking about forming, and comes up on this east side of the Sierra Nevada mountains and up past Pyramid Lake, right through Reno. And so on. So that's what we've got. So that's my report for tonight. And I'd like to bring our attention back to spiritual things. That's why I like to read out of the Bible, or tonight we're reading out of the Apocrypha. There were several books that were considered to be in the Bible, but were not included, and those were from the Apocrypha. So we're reading out of the Book of Wisdom, which was written by King Solomon, chapter 13. Wisdom, chapter 13. Surely vain are all men by nature, who are ignorant of God, and could not out of the good things that are seen know him that is, neither by considering the works did they acknowledge the workmaster, but deemed either fire or wind, or the swift air, or the circle of the stars, or the violent water, or the lights of heaven to be the gods which govern the world, with whose beauty if they, being delighted, took them to be gods, let them know how much better the Lord of them is, for the first author of beauty hath created them. But if they were astonished at their power and virtue, let them understand by them how much mightier he is that made them. For by the greatness and beauty of the creatures proportionably the Maker of them is seen. But yet for this they are the less to be blamed, for they peradventure err, seeking God and desirous to find him. But being conversant in his works, they search him diligently, and believe their sight, because the things are beautiful that are seen. Howbeit neither are they to be pardoned. For if they were able to know so much that they could aim at the world, how did they not sooner find out the Lord thereof? But miserable are they, and in dead things is their hope, who call them gods, which are the works of men's hands, gold and silver to shew art in, and resemblances of beasts, or a stone good for nothing, the work of an ancient hand. Now a carpenter that felleth timber, after he hath sawn down a tree, meet for the purpose, and taken off all the bark skilfully round about, and hath wrought it handsomely, and made a vessel thereof fit for the service of man's life. And after spending the refuse of his work to dress his meat, hath filled himself. And taking the very refuse among those which served to no use, being a crooked piece of wood, and full of knots, hath carved it diligently, when he had nothing else to do, and formed it by the skill of his understanding, and fashioned it to the image of a man, or made it like some vile beast, laying it over with vermilion, and with paint coloring it red, and covering every spot therein. And when he hath made a convenient room for it, set it in a wall, and made it fast with iron, for he provided for it that it might not fall, knowing that it was unable to help itself, for it was an image, and hath need of help. Then maketh he prayer for his gods, for his wife and children, and is not ashamed to speak to that which hath no life. For healeth he calleth upon that which is weak, for life prayeth to that which is dead, for aid humbly beseecheth that which hath least means to help, and for a good journey he asketh of that which cannot be set a foot forward, and for gaining and getting, and for good success of his hands, asketh ability to do of him that is most unable to do anything. Wisdom, chapter 13. So we're seeing how Solomon is talking about how people will worship nature, but they won't worship the creator of nature. They won't, that it's like they can't see the forest for the trees. Or they'll take a tree and turn it into a work of art and something that they end up worshiping that becomes an idol. So, it just, God doesn't want us to worship the things. He wants us to worship Him, the Creator. If you haven't given your life to Jesus Christ, I highly recommend it before it's too late. So I hope everyone has as good a week as possible. And Lord willing, we'll be here and do this again next Sunday. So I love you all and I'm praying for you. And until next time, God bless you. Go in peace and I will talk to you soon. Good night.